Okay, welcome back. Welcome to another course we did 1 to 8 Engineering Calculus 2 video. And today, I want to take a problem. In the last video we introduced the concept of the Riemann sum using our summation, our sigma notation to denote it, left, right, and sample point way of approximating the area. So let's look at how we can do it practically. Let's take a problem and see how that works in practice. So here we have a a call, okay, a call. The points have been have been given. So we have a 0, 5, 1, 6, 2, 8, and so on. And the question is about approximate the shaded area using 5 rectangles of equal width and left endpoint. So this is interesting. So how do we start? Well, since we're using left endpoint, what we'll start with is indicating what this area we want to look for. So from here, so that means we want to go all the way from 0 to 10, right? We want to go all the way from 0 to 10. So let's write out our left endpoint summation. What does that mean? We're approximating the area using left point. That area, the approximated area is equal to from I going from 1 to n and f of xi minus 1 delta x. So all we have to do now is to get out what each of these means. Okay, so that's just all we need to know. So starting off with the delta x, since it's the farthest, we know that, okay, we can use out off with the n. The n was given to us. The n is the number of rectangles we have to use. We can use any number, but they've indicated that it should be 5 rectangles. So n will be equal to 5. What about our delta x? Since they are to be of equal width, it means that we have to get the distance, the interval, and divide it by the number of rectangles, right? So it's going to be b minus a all over n. In this case, our b is the right interval point, which is 10. Our a is the first one, which is 0. And our number of rectangles is 5. So that gives us 2 units. So that means our delta x is 2 units each. So our rectangles, we have a width of 2 units. So it's b. So we can expect that if we're starting from 0, it should be 0 to 2, or let's put it down well so we can see. So it means our x sub naught is our starting point. Our x sub naught is always equal to our a, right? Which is equal to 0 in this case. Our x sub 1 is equal to x sub naught plus delta x. Is that not true? So that should be giving us 0 plus 2, which is equal to 2. And we can expect our x sub 2 will be equal to x1 plus delta x. So what we can say is that generally our x sub I is equal to x sub naught plus I delta x. So if it is x sub naught, our I is 0. So it means we're having just here will become 0. So it goes up. Our x sub naught is equal to x sub naught, which is 0, which we will always be given to us, which is our a. Then our x sub 1 will be equal to x sub naught plus 1 x delta x. Our x sub 2 will be x sub naught plus 2 delta x. You can expect that. So using this, we can quickly get out what we want. So instead of writing this, what we're trying to get used to here is the idea of simplifying things for ourselves as much as possible. So we can tell that this is what we'll have. I delta x is that not true? So the only difference is that we'll just plug in values now. So we can expect that our x sub naught, let's just quickly put that down. We can expect our x sub naught will be equal to 0, x sub 1 will be equal to 2, x sub 2 will be equal to 4, x sub 3 will be equal to 6, x sub 4 will be equal to 8, x sub 5 will be equal to 10. Okay, so since we're using 5 rectangles, and since it's left end point, we're starting from x sub naught, remember, xi minus 1, and now I is starting from 1, so it means we're starting from x naught. So it's x naught, x1, x2, x3, x4 are the 5 rectangles we're going to use. So it's going to, the first rectangle is going to go from 0 to 2. Let me use a different color to indicate so that the point comes out clearly. So our first rectangle is going to have from 0 to 2. The next is going to be from 2 to 4. The next is going to be from 4 to 6. The next is going to be from 6 to 8. And the next is going to be from 8 to 10. So 1, 2, 3, 4, 5. We have that. So what will be the heights of each of the rectangles? Well, by using left end points, it will correspond to the height. Remember the function. This function f of I minus 1 is telling us the height. So it's going to equal the value of the function at the left end point. So between 0 and 2, the left end point is 0. So it's going to be the height at f of 0, and the height at f of 0 is 5. So from 0 to 2, the height of the rectangle would be 5. I hope that gets okay. I didn't do a very good job. Let me see if I can bring in the trusty ruler. Let's just get that clear. Okay, so I'll be having this. Again, I did a very good job with spacing out, but let's move on. Next thing we have is from 2 to 4. The height will be the height at x at f of x is equal to 2. So we know that this is what we'll have. It will be here. So between 0 and 4, we'll be having something like this. Okay, no, I should have just I'll end it up. But you can feel free to just keep all of this. I just see the final thing at the end. But if you want to follow me my struggle. Oh, always welcome. Okay, so we have that it's going to be something like this. Then at 6, it was has to be that same height. So we have this. Okay. And between 6 and 8, the height is going to be the value at 6. So we're having this. And the continuous. And then between 8 and 10 is going to be the value of the function at x is equal to 8. So you can just take it down. Okay. Yes. Let's end this here now. Okay, so this is what we have. And we've done this. So this is just the approximation using the left endpoint. So all we just have to do now is to find the value of the rectangle. So this is area 1, this is our area 2, this is our area 3, this is our area 4, this is our area 5. So we just have to calculate the areas of each of this, add them up, and that's our answer, right? So what do we have here? What do we have? Well, we can quickly do that. The final area is approximately equal to area 1 plus area 2 plus area 3 plus area 4 plus area 5, or basically what this function is saying. So the summation of all of that. So how do we get that answer? Well, our delta x is common to everything, so we can bring it out. The delta x is 2, so having 2, then into brackets, the f of x of each of this, so of xi minus 1, starting from 1. So it's x0, x2, f of f of x0, f of x2, f of x4, f of x6, f of x8. So that's what we're having. So here will be 5 plus 8 plus 9.5 plus 7 plus the final one, we'll be having it as 1. So it's just the addition of all of this for us to get our answer. What do we get? Anybody trying it out? Okay, so it's going to be 6 to 1. 6 to 1 square unit. Square unit, so that's what we have. So using the left endpoint, this is what we have. Quickly, this was interesting. We just know what we're here to do, get all the things necessary, and please, this should be at 0. So this was straightforward, right? You get out what we have here, get out what each of the parameters mean, just understand what the expression is saying, and go home dry. So what we're going to do next in the next video is to solve the same problem using the right endpoint. And the reason why we're trying to do all of this, not just for for the heck of it, yeah, is to master it. But for us to say, is there anyone that gives us a better approximation? That's what we want to answer. So just keep that in mind as we're doing all of this. So we'll do the one for the right endpoint, and we'll also do the one for the general sample point, where we'll use the midpoint, the sample point to be the midpoint, and we'll see how we can compare all of them. See you in the next video.